part 1 asks us to show that this choice of P star and the strategy for our online algorithm achieves a certain competitive ratio. And so let's just remember what a competitive ratio is and how it will apply to this problem. So we're comparing our online algorithm to the optimal clairvoyant algorithm that can know the future. And in this case, that means that the clairvoyant algorithm opt can always sell at the maximum price. We only see the price each day as we go along. Opt sees the overall best price, so opt can always sell at the max price. This is a maximization problem, so our price is always going to be less than or equal to the optimal price. And because opt can always sell at the max price, then for our analysis, what we really want to know is what's the ratio of our price with our algorithm to the maximum price that is seen over the 90-day period. And we need a bound that holds in all cases, and in particular in the worst case. So to think about this, there are two scenarios for our strategy, because our strategy says, if such and such conditions hold, then do one thing, and otherwise do another thing. And so what we want is the overall worst case. So what we're going to want to do is consider all possible scenarios under our strategy and find the worst case out of the worst cases for all of those scenarios. So for our two scenarios, we do one thing if the price goes above P star, and we do another thing if the price stays below P star. So we want to analyze each of those cases, see what the worst case ratio between our price and the maximum price that's seen over 90 days is, and then take the worst of those worst cases as the overall worst case, and that'll give us the competitive ratio. So if you haven't already, go ahead and try to analyze these two scenarios and see what the ratio would be in each case. Okay, so let's just go ahead and draw that out. I think it's helpful to draw out the little time series to see what's going on. So let's look at our first scenario. So now if the price goes above P star, then the price starts somewhere, it goes above P star at some point, and we sell. And now, what's the worst case? Well, the worst case is if after we sell, the price goes all the way up to this upper limit. Okay, and that is the worst case because opt can just sell when it reaches the upper limit, and so that's the maximum distance between our price and the optimum price. And if we just sketch out that ratio of our price to opt's price is in the worst case, so at least P star over U, and plug in for what we set P star to, root U times L over U, and we get square root of L over U. So that's our ratio in this scenario. And now if we consider the second scenario where the price stays below P star the whole time, well, what's the worst case? Worst case would be if the price, so we're selling on the last day if the price is never above P star. Worst case is if the price drops all the way down to the lowest level possible on the last day. So there's a little gap here, but there shouldn't be. This should be at L, at the lowest level, whereas before the price was much higher. So we would have done better to sell earlier, but we didn't know that at the time, and we ended up getting stuck with the lowest possible price. And in this case, what's the ratio of our price to opt's price? Well, opt's price up here is P star, or just a little bit less than P star, but asymptotically it would be, it would approach P star. And our price is L, so the ratio of our price to opt's price is L over P star, or it's at least L over P star, and so that's L over root U times L, and that is square root of L over U also. So now, in either scenario, the worst case is root L over U, competitive ratio, and so that's our overall competitive ratio. And that's it for that problem.